Thank you, John. So a couple of things I want to bring to your attention. Yesterday, we talked about how Inspur came to OCP with the concept of open RMCs. So they are one of the very many members that are now getting on to the open RMC. Mark Rennick yesterday mentioned the fact that we have 124 products on our marketplace, and we have 60 more in the pipeline. You just heard John Hu talking about some of those products that you will see coming up on the marketplace in the next 3 months or so. Very, very excited. So what you can see behind me is the collaboration, the kind of collaboration that Inspur has done with OCP. They're collaborating with OCP on a global scale, across geographies, across environments, across cultures. We've started to also engage with other companies, but this is the kind of collaboration that epitomizes what OCP stands for. So we're very, very excited to have Inspur come on board. My next speaker is going to be talking about collaboration as well. This is collaboration in the telco environment. And OCP members, along with the Open Networking Foundation, got together and decided to adopt OCP for broadband. And this is something new. We were really excited to talk about broadband services and how collaborating on various aspects of technology would offer complete solutions to our adopters. Together, these three organizations, ONF, AT&T, and Flex, are not only going to provide open together an opportunity, but also be better together. We will first start with a perspective from AT&T. Abdellah Tazi is responsible for corporate strategy of technology evolution through research, ideation, and evaluation, especially for wireless services and wireline broadband services. These three things, research, ideation, and evaluation, are very key to OCP adopters. And they're really the key to successful collaboration. Then we'll hear from the Open Networking Foundation's Saurav and how they utilized OCP with the help from Flex and AT&T to make SIBA and Trellis ideas a reality. And finally, the evaluation part. Flex provided the integration and the validation to ensure that this was a complete solution, and that it was easy to deploy, and that it was easy to adopt. Research, ideation, evaluation, all for success, all open, all together. Please help me welcome our first guest, Abdellah Tazi from AT&T.
Thank you, Archana. Somebody in the back just told me this will be an easy time for me. Pretty much the audience go to sleep right now. I hope that's not true. OK. Open access. First of all, let me level set. What is access? Access means different things to different people, depending where you come from and where you work, basically. For the telcos and the wireless providers, access means the edge of the network. It really starts at the edge to the customer premise. And the customer premise could be a cell site. It could be an actual broadband user where we have CPEs or terminating equipment. So having set the stage, you will hear the words access and edge used quite interchangeably, because they're really the same thing. To enable or to open up the access, we need to start with disaggregation. Disaggregation of the software from hardware and disaggregation of the control plane from the data plane. Only then we'll be able to go to an open hardware and an open software with open APIs and realize on automation, zero-touch deployments, and such. Then again, to get there, we have to work within the traditional standards bodies to ensure what we put out there is interoperable. Traditional organizations such as 3GPP, IEEE, FSAN, ITU, and to further take that collaboration and that work into the open standards communities, such as ONF, ORAN, and ONAP. Now, what's driving AT&T's white box strategy? It's software-defined network. You gotta go white box before you open up the software and the hardware, as we said earlier. So we started at the data centers, the regional data centers, the central data centers, and now we're moving to the edge or the access. And really, at the edge and access, that's where the opportunity. A speaker before me earlier talked about 5G opportunities. We're going to be deploying 5G. We're densifying our network, and we will densify more when we deploy 5G to provide connectivity everywhere. When we do that, we have a lot of opportunity to build up the edge with OCP-based boxes, with open software, and pretty much open solutions. As the volumes go up, the cost of the hardware goes down. And when the cost of the hardware goes down, of course, CapEx and OpEx goes down, and everybody benefits. We started the white box journey by submitting OCP designs a few years back for the cell-side gateway, for the universal CPE, and this morning we submitted another OCP design for a converged access gateway, which sits at the cell site and enables us to deploy 5G and realize on the stringent latencies 5G requires, as well as the huge bandwidth requirements demanded there. So where did we start? We started with closed solutions, rigid models. We get vendor solutions, vendor-built hardware, vendor-provided software. The room to accelerate production or to move forward at a fast pace was very limited. So we went into a disaggregated model where we engaged OCP and we engaged open software communities such as ONF to get the building blocks to enable an open solution in order to move fast and to be agile. So as an example, in the broadband services we offer, we are engaged in trials where we disaggregated the PON OLT, which is the packet optical network solution. We went to OCP through an OCP design, and we had EdgeCore provide us with the devices. We connected everything, and we provided a solution, switched through the top of a rack, and built a CEBA pod, which is an open compute platform or pod, basically, and got the open software from ONF, Volta and CEBA, which Saurav will be talking about in a few minutes. And we rolled out the solution, and right now we have live users on the solution demonstrating how open networking and working together with the open community and the open compute platforms allows us to achieve our goals in an agile fashion. Can we go back one slide, please? Sorry. Thank you. So please join the community. Without your participation, we can't realize on our objectives. And with that said, I'm going to go ahead and invite Saurav to the stage.
Thank you. Hey, thanks, Abdellah, and hello, everyone. So as Abdellah pointed out, AT&T's focus and the focus of a number of operators worldwide is in the last mile. And that is where SEBA comes in. So SEBA stands for SDN-enabled broadband access. And when we talk about broadband, we're talking really about fiber to the home networks, or fiber to the business, or fiber to the curb. But we also call this by another name. This is passive optical networks. So there's many varieties of it. GPON, which is the gigabit version, XGS-PON, which is the 10 gig version, or GE-PON, and so on. But the concept is all the same. That is that at the telco central office, there is an optical line terminal, or OLT box, which is the head end for this fiber distribution network. Typically a 64-way split that goes to the end user, whether that end user is in a home, or a mobile base station, or a business enterprise. So in SEBA, for the OLT, we use OCP hardware, OCP-accepted hardware. This particular instance is from EdgeCore. And there can be 16 of these in a SEBA pod. And each of these can sustain over 1,000 subscribers, so about 16 to 18,000 subscribers in a SEBA pod. Now, upstream from this OLT, we connect to top-of-rack switches. And again, these are OCP-accepted hardware. And they're basically the same data center switching hardware that you see in many other presentations. And these switches then upstream connect to what we call routers, or external BNGs, and also to the local compute. Now, the local compute, again, is OCP-inspired hardware, this time from Quanta. But this is where we put in all our software. So this is the SDN part of SEBA, where all the software that runs this hardware is outside the box, hosted in the servers. So Volta is a very important component. It stands for Virtual OLT Hardware Abstraction. Its job is to present not just the OLT, but the entire PON as a switch to the SDN controller outside the box again, so that the SDN controller sees the PON as well as the aggregation top-of-rack switches really the same. And that's where all the features of this network are brought out, whether it's AAA or DHCP or routing or bridging and so on. And then on top of that, we have a piece of software we call the Network Edge Mediator. Its job is to orchestrate this entire pod and manage the life cycle of all the separate components inside the pod, but also to interact with the operator's backend systems, the OSS, BSS systems. So all of our software, there's about 50 or so Docker containers that are managed by Kubernetes and installed using Helm charts, and all of that happens inside the pod in these servers. So that, in a nutshell, is SEBA, and we have worked very closely with the Open Compute project, as well as AT&T, as well as brought together this community that has helped develop this. None of this would be possible without this community. They're OCP members, ONF members, and some of them are joint ONF and OCP members. So to give you a look at what we really are talking about in this joint collaboration, think about what it means to be a white box. To us, a white box means that it has to have open hardware specs, which is what you get from the OCP and built by an ODM such as EdgeCore. And it includes open source software that comes from both the OCP and ONF. So ONL and ONI are examples of software that comes from the OCP. Typically, the chip vendor, this part is closed, but actually, it's not open source, but it supports open APIs. In this particular case, it comes from Broadcom. And then everything above that comes from the ONF, and it's completely open source. So there is a version for the 10 gig PON, and then there is another open spec that is coming from Deutsche Telekom for GPON-based box. And the same software stack will be running on that box as well. Similarly, we're still talking about white boxes, but this time we're talking about these top-of-rack switches. Again, we have open hardware specs that are coming from the OCP with a vendor like EdgeCore or Delta building the box around it, and the software coming from OCP and ONF. So again, ONL and ONI are something that comes from OCP. We use it inside the box. The chip vendor's SDK is typically closed, but does support open APIs. And then we build the software on top of that, and that is all completely open source. Now, this top-of-rack switching, if you saw in a CEBA pod, there's typically 2 of them for redundancy, and that's all we use inside a CEBA pod. But the top-of-rack switches themselves are actually expandable to an entire leaf-spine fabric. Okay, so you can have these top-of-rack switches that connect to the local compute, that connect to the access hardware, but you can expand them horizontally through a leaf-spine fabric. In fact, you can go, you can not only connect to the upstream networks, the metro or core networks for that operator, but you can also go deeper into the network, even closer to the end user by extensions to this leaf-spine fabric, and then have all this access hardware connect to the field office equipment. So this is a separate project itself in the ONF. We call it Trellis. It's built, again, SDN-based. It's built on top of ONOS and supports a number of features. And in this particular project, we work very closely, again, with the OCP and a different operator. It's Comcast this time. And this is actually in production trials at Comcast as well. And again, we cannot do this without the support of our community, our vendors, our partners. So talking about community, the ONF, I've actually given you a very quick introduction to 2 projects, CEBA and Trellis, but we actually have 10 or more projects. All of them are under what we call the CORD umbrella, or CORD stands for Central Office Re-architected as a Data Center. And we have 160 members. We are a vibrant operator-led consortium, so the very top we have our operator partners that guide all these open source projects that you see on the right-hand side. They guide the direction of these projects into what they need. So if you're interested in learning more, please do visit our website. It's opennetworking.org. These operator partners, we call it curated open source. So they are guiding the direction that these open source projects take. And once that guidance has come in, we have ONF itself has a 25% strong engineering team that deliver on these projects, working very closely with our community. As you can see, a couple of examples that I gave you in the 2 projects that I talked about. So a very important part of this community is the next speaker. I'd like to please welcome Chris Winslow from Flex, who will give you a lot more details about how Flex is working as part of this community. So please welcome Chris.
Good morning, and welcome to the Telco tag team. I want to thank everybody that's participating in this. It's been a really exciting show this year for those of you that have been here for multiple years like I have. The amount of enthusiasm and participation has been outstanding. Flex has had the fortune to be part of the infrastructure build out for over 30 years. We have participated in almost every area of the telecommunications infrastructure, the cloud infrastructure, and everything in between, and have likely built much of what you see today in many of the data centers, as well as in many of the central offices around the world. We think we're on the edge, though, of one of the biggest transformational changes that the telecommunication industry has seen in more than 50 years. And that's, as people have talked about yesterday and today, centers around the edge, access, and how the transformation is going to happen based upon changes in use cases, changes in the market. We see with the advent of 5G and an explosion of new applications that'll be driven by that, that's going to push things to the edge, and it's going to be required to create a new infrastructure in order to support the low latency applications that are going to be needed, as well as the variety of different applications that people are going to want to drive at that edge. And that's critical as we move forward. And we feel fortunate to be part of that, and we believe that it's an enormous opportunity, not just for this open community, but also for the legacy providers that have been in this space, the legacy carriers that are in this space, as well as all the new emerging players. But much like this logo that you've heard all the last couple of days around being open together, it's really going to be critical for that to happen. Because in the telco environment, it was touched on earlier, there is a significant amount of overhead that's required that doesn't exist in other parts of the market. And that is that it's a regulated environment in most places. It meets particular standards, and if you think about it, regardless of whether you're going to use open hardware and open software, or whether you're going to use legacy implementation, when somebody picks up that phone and tries to call somebody in Delhi, there is a requirement to go through those networks and somebody's going to pick up on the other end. That doesn't go away because we move to an open architecture. So one of the big areas that we think is really critical now is around how do we do system validation, how do we do software stacks. So we're heavily participating in working with our partners in the traditional networking, server storage, and telecommunication infrastructure market around next generation hardware. We're also very active with OCP. We're one of the founding members of OCP19, and feel very strongly that there's going to be a need for that wide variety of open community hardware. At the same time, we're also participating in many of the industry groups like ONF, Cord, TIP, and others around the development of that software stack that's required in order to make this disaggregation work, and frankly create those new opportunities for both the incumbent players as well as the emerging players to be successful. And at the end of the day, it's going to have to be integrated into a platform that can be deployed. Today, there's an enormous infrastructure that's been built around the world for telecommunication that allows for consistency, reliability, implementations that are tried and true, that have become an accepted norm for everybody that has ever owned a telephone or connected through broadband. That needs to be replicated and continued once you move forward into the next generation. So as Saurav mentioned, we've developed an open standards engagement lab in our Milpitas facility, not too far from here. We've worked with both emerging players in the hardware space and many of the consortia to create an environment there that can be multifaceted. We also work with the legacy telecommunication providers, because when you think about open and you think about interoperability, over the next couple of decades, this isn't going to be just a transformational change where a few open players all of a sudden take large portions of it. This is going to become a transitional period where our legacy providers are going to be very strong and going to come up with new innovative solutions, and there'll be new players that are emerging into the marketplace that are going to take advantage of this open architecture and open technology in order to create new innovation. So we feel like we're in a position with resources, with engineering capabilities, with technologies in order to create that common community to allow people to create that test and innovation opportunities around integration with legacy providers as well as in the new world. We're going to talk a little bit this afternoon in another breakout, more technical session with one of our leads in that area around what we call FAST, which is a foundation for automated system test. We've developed technologies inside of this engagement lab that allows us to create different telco simulation environments between the legacy infrastructure that exists today, new architectures, and new open software that allows us to take advantage of what ONF's done with SIBA and with Trellis, and as Saurav said, 10 other projects that they're working behind that. And we've been fortunate to have a multi-year relationship now with AT&T in this space to help them as they've developed massive amounts of new innovation around this disaggregation and openness in the telecommunication world. So I encourage you, if you have time this afternoon, to sit in on the validation and SIBA Cord presentation that we'll be doing at 2 o'clock today. we feel like we're on the precipice of something really dramatic. And it's exciting to see OCP really embrace the telco side in addition to the cloud side. This aggregation that we're going to see over time between the different carriers as they look to change the way the infrastructure works is going to be exciting. The bottom line is really going to be about how fast you can get to market with new services and new applications, how much you can change the marketplace around the world, and that's going to rely on this open architecture in order to do that. It's also going to rely, though, on organizations that are committed to upholding the reliability standards and the capabilities that are necessary in order to deploy it. So with that, I'd like to ask Abdellah and Saurav to come back up for us to close out on this for you. And go on.
Thank you, Chris. So really, we can only be open if we work together, if we all, operators and suppliers, join together, join forces, and join the open communities. Open communities meaning the open compute projects, as well as the open software communities.
Yeah, and any open source project lives and dies by the community it creates. So if you liked what you saw over here, if you're interested in the work that we are doing, please do join us and we can be open together. Thank you.
Thank you.
Thank you.